Let's solve LeetCode 1161, maximum level sum of a binary tree. This is a daily problem on January 6th. And essentially you just want to find the level that has the maximum sum. So if we consider these levels as one base, so this is level 1, this is level 2, this is level 3, you will see that 7 and 0 give you the best level, and that's 7. And so your second level is your best level, and you'll return 2. So of course, you can see that we're likely planning on doing a breadth first search, also known as a level order traversal. So if you haven't solved this question, I would recommend solving another question. It's called binary tree level traversal or something. I'll link it in the description, and then you should be able to do this one with relative ease. But the idea is the following: you have to create a queue, add it to, or add your root, and then add its children, and keep it going from there. So I'll write the code, and this is just code you're gonna have to learn. Typically, it's like you just memorize this, but of course you should understand how it's working. So right here, I would actually put a root check, and I'd like return -1 or something. But the problem tells us that we'll always be given at least one level or one node or something. So I don't actually need that. So I'm going to add my root to my queue, and now I'm going to declare the size, or rather I'm going to declare a levels variable so we actually know what level we're on. And I'm going to call our best level to 1, since we'll always know that we won't have like a 0 level or anything. So by default, our best level is 1. I'm going to initialize a while loop, and while our queue is not empty, I'm going to declare our size, and our size is, let's say, queue.size. And outside this variable, I'm actually going to keep track of the best amount, so we know like if we find something that's better than our current sum. And for now, I'll call that to the lowest possible value, and that's in Java called integer.min_value. And so that's basically our template. So this is how it'll look. I mean, besides these two lines, this is how most of your breadth first search will actually look. And the process after that is relatively simple. So now we're just going to do a for loop through the levels. Give me 1 minute here, where you have to do a for loop through these levels. And so we can do that by going through the size variable, and the size is telling us how much elements are currently in our queue. And so I'll simulate this after, but I'll do like a walkthrough of the code. But essentially your queue will always store the children, and we do that by taking off whatever's currently first in our queue. So that's queue.pull, and I think I call it queue. And I also need another variable here. Let's call that amount. And I'm going to add that amount to our node value. And then I'm going to look and see if that node that we're looking at has any children. And if it does, we need to add it to the queue. And similarly for the right side, I need to add the right side if it's not null. I'm going to increment my levels because at this point we're done with the level we're looking at. And then I'm going to check if we have a value that's bigger than our best amount, currently, then we know that our best amount needs to change, as well as our best level needs to change to our levels. And at the end of the day, I'm going to set this back to 0, and we're going to return our best level at the very end. And you can see that works. So allow me to simulate that for you. Apologies for my voice in this video. I am a little bit under the weather. But let me set up a whiteboard example and I will be back. Alright, so we have the code here as well as we have the example. And let's just walk through it together. So we're going to initialize our queue. Initially it's empty, but then we add our root. And our root of the problem is 1. So let me add that to the queue. And let's call max, let's just call that -1 for now. Best level is 1, levels is 0, and we enter the queue. Or we enter the while loop rather. And our amount is 0, and our size of the queue is 1, as we can see here. So our for loop will be going from 0 to 1. Our node is actually taking off the first element of the queue, so we're looking at 1. And let's point out before we keep going that in our queue we're storing nodes. We're not storing integers, but for the sake of representation I'm putting it as integer. So since we pull from our queue, we're actually removing it from here and we're taking it here. Then we're going to add the children of that node into the queue. As you can see from if node.left doesn't equal null, node.right doesn't equal null. So let's add 7 and 0. Then we add our node.value to our amount, which is 1. And then we exit our for loop because we hit, we increment I, and I is equal to 1, and 1 is not less than 1. Or 1 is not less than 1, yeah. So now we increment levels. We're at this line now. And if max is greater than amount, which we can see max, or if amount is greater than max, which we can see it is, we're going to update best level and we're going to update max. So let's do that. So best level is now equal to 1, which it already was, but and max is equal to amount, which is 1. And then we set amount to 0. Okay, now we enter all the way back to our top of the while loop because our queue is not empty, and we redeclare our size. This amount equals 0 is kind of unnecessary, but now we declare our size again, which now our size is 2. And our amount is 0. Now we enter the for loop, so we're going from 0 to 2. So now the node we're looking at is 7, and we'll pull it from here. And 7 has 2 children, so we'll add the 2 children, 7 and -8. And then we'll add 7 to our amount, which is 7. Now we'll look at, we'll go back to the top of the for loop because I is now 1. And now we will be looking at 0. So our node is now 0. 0 has no children, we won't be adding anyone, but we will remove it from the queue. And we'll add 0 to amount, which 7 plus 0 is 7. And then we increment levels because we ended the for loop. So now we do this check here. If amount is greater than max, in this case it is, we update max, and we also update best level. And you should see how it's working now. I mean, now we set amount back to 0. We enter the top. Our size is still 2. We pull 7. We add it to amount. There's no children, so we're not adding anything to our queue. Then we go back to the top. Now we're looking at node 8. We add -8 So this will be -1 rather. It has no children. We don't update it because it's not greater. Amount becomes 0. We enter the top of the while loop. The queue is now empty, and we return best level, which is 2. So I hope that was helpful. Sorry about if my explanation wasn't clear. If it wasn't clear, please leave any comments. And you should be able to do level order binary tree traversal. So yeah, thank you so much. Take care.